that's okay. Peter, the floor is yours.
Thank you, Joop. Thank you very much for giving me the opportunity for this keynote, and thank you all for joining in. So it's before lunch for me here in Ireland, so I know everyone else has finished their lunch at Central European time. My presentation should take around 20 minutes, hopefully, today, so there will be a little bit more time for questions. I'm looking at three aspects to this presentation. I'm not necessarily dealing with them in linear fashion, but I will be talking about what I consider some of the state of the art in volunteer geographic information and crowdsourced geographic information. Integration with authoritative data sets is with the end product of creation of knowledge products such as linked geodata. Of course, in any talk about VGI, about CGI, and about integration, we cannot escape talking about things like data quality, about interoperability, and of course, I suppose, applications which sit on top of this integration. And one of the questions I ask myself when thinking about this keynote is, can the communities that are involved, the volunteered geographic information community, the crowdsourced community, governmental agencies such as national mapping agencies, and the geospatial research community converge and collaborate more? Because I have a small fear that different aspects of geospatial integration is pulling people in different directions and maybe making it a little bit more difficult to collaborate. A nice diagram from Harris and Lafon in 2012 is showing that volunteer geographic information and CGI is a new paradigm. And I suppose the old paradigm, and it's not true to call it old in that it's not disappeared, is that it was a top-down approach in terms of data and information from maybe a federal level or a national level, working its way down to the end, to the bottom, to the individual. But in the last 10 to 15 years, with the advent of VGI, we've seen individuals and citizens become the top of this, or the base of the pyramid as such, and become a source of spatial data. Now, there is a fear when I talk about the old days that I'm like the gentleman here in the famous painting, that I'm the old man telling the children how it used to be in his day. And I do remember the time at the beginning of my career where there were serious lack of opportunities to integrate data. There was difficulty in making the software work. That very often 20 years ago, if you had software that read a format or a structure, it wasn't really very good at doing anything else except that. Standards had not really become as pervasive as they are today. And I can remember the days of being very proud of owning a 1 gigabyte USB key and being able to exchange data, of getting access to a server that had 500 gigabytes, for example. Almost difficult to think about now. And the mindset, I remember when I was doing my PhD now, close to, well, it's a little bit more than 15 years ago. And it was strange that someone in computer science was so geographically orientated, because that was just for GIS people. So all of this made integration a little bit difficult because there were so many factors that were unavailable. And if we look at integration from a dictionary sense, I'm less inclined to go with number B here, which is out of usage anyway, to complete or perfect, but rather integration of data, be it geospatial or not, is to bring together parts or elements to form a whole. But we don't have this emphasis on the end product or the whole being absolutely perfect, but it's an end product that should be usable. And I am guilty in my own teaching of spatial databases and GIS, of sometimes putting these flowcharts online and in my PowerPoint for students. And in reality, data integration is never as easy as the flow charts and the infographics and the diagrams show. It's never just a case of extracting, transforming, and loading. There is a lot happening, and a lot needs to happen before we can say that we have taken data set A and data set B and integrated them in some way. So it's often a case where students have seen these nice diagrams, and then when they begin their project and look at trying to integrate spatial data, they realize that there's a lot more problems there than these diagrams would suggest. So a more realistic flow chart of my feeling about data integration is that you start in a little bit of a messy way. You probably start again, and then without really making much progress, you at least establish the fact that you're not at the beginning and you move on. Of course, this is probably more of the old days rather than today, because the software is much more mature now. We have many more services. The data is being exchanged in a more interoperable way. So it's quicker to make progress in terms of your data integration. One of the, I suppose, key books on data integration from a computing science point of view is Halevi et al. In 2006. And they start the book with, the textbook with, a definition which, regardless whether this is geospatial or not, works, because data integration is a pervasive challenge when you're trying to query across multiple autonomous and heterogeneous data sources. And I suppose this slide here is an integration 101 on why data integration is difficult, and is difficult in the geographic sense, that we have to deal with geographic areas and scaling issues. How will the data sets actually interact with each other? So from a technical sense, there's semantic interoperability. Is the water feature in A the same as what we're meaning by water feature in B? The quality and the accuracy, how has these data sets been captured, manipulated, maybe restructured, etc. And more and more, particularly in the last 3 or 4 years, there has been more interest in privacy around the integration of data, that taking a data set and integrating it with another can make a rather fuzzy picture of what the privacy in terms of commercial or even personal actually is. And this, of course, feeds into legal issues of licensing, reuse, intellectual property rights, and then reproducibility. So academics who are doing data integration, would they able to produce reproducible work given the constraints of the data sets? And then, of course, sustainability for people like mapping agencies. Is it sustainable to do certain data integrations? A nice diagram, which it's a couple of years old now, but certainly captures the broader landscape of integration from the UN's Global Geospatial Information Management wing committee. And what we have here is we have new sources, big data and other sources. So these are now crowdsourced, I would assume, without reading through the details. And these are now put on the same footing as the traditional and historic and well-trusted data sources of the past and today: surveys, censuses, administrative data. And we have this pyramid again. Integration happens after all of these, I suppose, both technical and socio-technical things happen, and integration must happen. The ordering here is probably reorderable, because interoperability probably has to happen at the same time as integration. So there's many reasons why a national mapping agency or a government agency would consider integrating crowdsourced information. On the top right of the slide here is a well-cited paper from 2017, which looked at a survey of European national mapping agencies, and it looked at the usage of VGI in those mapping agencies. Change detection and report alerting were the two most popular purposes of using VGI. In more recently, Map Gretel from National Land Survey of Finland and some academic work is a way of allowing user contributions of showing where buildings do not exist anymore, for example. So the reasons are varied. It's a resource issue. Crowdsourcing is not free by any means, but it can allow you to collect or generate information that may be costly for you to generate. It may be a very good tool for public engagement. So if you were in session 2 earlier for some of the talks by national mapping agencies, public engagement was a major win from this type of integration. And then there is an opportunity to generate new forms of information that you may not already have. And two slides from that presentations session earlier in this conference looked at different contexts and applications. And of course, there's the concern about data quality. And sometimes data quality is the issue when the crowd is supplying the spatial data. But then in the example of Poland here, we found that the crowd was actually performing error detection and change. So the data quality issue is a little bit different. Of course, other actors can consider integration of VGI, authoritative and CGI for many other reasons. So this might be a commercial company. It would provide a unique view. It would allow you to see new patterns and maybe see some societal pressures or issues. Of course, some of the issues that cause problems in the setting for mapping agencies or governmental agencies is that there may be difficulty with working with different types of open licenses, of understanding suitable conditions for reuse if it makes economic sense. So a lot of the industrial actors have to answer these questions for themselves before they go ahead and perform integration. But when you've actually figured out that you actually want to go ahead and do some integration, then the actual work starts. And I suppose without providing many references, because I think it's almost obvious, particularly to the audience here today, that semantics are the most difficult and most common issue. We have figured out a lot of the technical and operational questions. So maybe we could classify things as easy versus hard geodata integration problems. And we could have easy problems, which I would maybe refer to as low-hanging fruit, that might just require access to a WMS or a WFS, and that already solves a lot of the integration problems. Whereas the deeply buried diamonds, the really new information, the new data that can be generated, may require a lot more work. For example, you may require a conversion of your own internal data to linked geodata, for example, to take advantage of the vast ecosystem of linked geodata that's out there. So the actual work, as I said, on the left here, we see that, the standard kind of geocomputation work, that we're matching polygons, or we're looking at line overlays, for example. And on the right-hand side, we have more of the semantic approach here, that technically, syntactically, I think we're in a very good place, but then semantics is still an open problem that is being tackled in many different ways. And it may be 7 years ago now, but Professor Janowitz from California, who will give a keynote later, in a paper back in 2013, asked 7 research questions for geosemantics. And I think they're as relevant today as they were then. I don't think we will have a solution to them anytime soon, but you can probably work through them and see that there are some questions that apply to certain problems. So this maybe goes back to the idea of the easy versus hard. So what kind of geospatial classes should be distinguished? Depending on the problem, that might be easy or difficult. How to process, publish, and retrieve geodata. That problem is far more mature now than it probably was in 2013. Moving objects, event discovery. These are very interesting problems and will require integration of data before they can be answered. And of course, linked data. There's a really good open access book published by Edward Curry from National University of Ireland in Galway, looking at real-time linked data spaces with the sensor, the overtake of sensors in our houses, in our offices, in our vehicles, in our everyday life, converting to linked data. And then we have the data dissemination to sometimes different types of consumers. It can be a vehicle, it can be another sensor, it can be software. So this is where we have a very large and difficult problem. But with sensor web and with those type of approaches, this is becoming much easier and much more frequently available. Of course, asking a question such as where are there areas that are suitable for creating a business park, that might sound to certain end users like a simple question, but where are there areas is probably an easy question, but asking suitability then means looking at a lot more of the semantics of the problem. And here we can see an ontological approach with two data sets. And this is not an easy problem either. In Ireland, we have a linked geodata with Ordnance Survey Ireland. There was a presentation in one of the sessions this morning from the representatives of ADAPT, and the applications are almost endless when linked geodata is made available. But it's taken a long time and a lot of work to do that. But then one of the really nice outputs are currently in Ireland is the COVID-19 data hub, which the public have really taken to. So a lot of maps there, a lot of downloadable data, and people can keep up to date with the coronavirus pandemic response. So coming close to the end, the academic research community, of which I'm a member of, is still very busy around looking at the conflation of authoritative data, VGI and CGI. What I'm seeing is that, and I'm an editor for one of the journals in GIS, and I'm seeing the vast majority of papers that come to my desk are exploring machine learning and AI approaches. I feel that's the dominant topic in state of the art at the moment. One of the things that academic research need to look at, and we flagged it before, is that there's not really a clear feedback mechanism when a lot of academic research is performed on crowdsourced data. So if we find problems with the data, it's not always fed back to the communities that generated it in order to help them improve for the future. What we're finding in academic research is that there is a lot of work going on in combining remote sensing imagery databases with data sets like OSM. So two examples there, different approaches. Deep learning approaches is the commonality here. Semantics, obviously, then to pick out the features and to extract what we're looking for in those data sets. 3D data models from OSM and satellite imagery. The fact that these data sets are globally available is what makes them attractive for these type of products. And of course, another example of change detection using deep learning approaches, but then using crowdsourcing to verify the output of those algorithms. We find that there is work going on, for example, in the JRC at looking at how OpenStreetMap and Inspire could integrate. But what you're finding is by its very nature, the two of these are two very different entities. And where one has a pro, the other has a con. And there's a very nice presentation available online that looks at that problem. So there's a lot of commonalities, but there's still a lot to work out in terms of how these projects might converge, but are very different just because of their nature. OSM, of course, has what we term a simple semantic approach, but yet I feel it's yielding major influence in research at the moment. And it shouldn't be undervalued in any way. It's an open approach, but it's yielding major influence in academic research. Something then to finish with that I suppose is coming down the line is that we'll look at integration is the European data spaces. And these will look at a sectoral approach to integration of data. And it will look at high value data sets, which will be those from national mapping agencies, but it will also look at personal data spaces, which would include crowdsourcing. So just before my final slide, a sincere thanks to Julia, who's been just a star player in terms of the technical setup for the conference and always being there to answer questions for us. And Rob and Joop, who've also worked very hard and invited me here, and of course you, the audience. So my final slide is just two fake tweets. So I'm not actually on Twitter, but just to round up that geospatial data integration means lots of things to lots of people. There's very mature tools and technologies, but integration is still a difficult problem and will be going forward. But I do think that collaborations don't happen overnight. They take time to foster and sustain. So workshops like these that bring different actors together are very important. And the open data approach probably brings the best middle ground for everyone, so that everyone can have something on the table that they all have a stake in. So I will stop there and thank you.
Thank you very much, Peter, for your excellent presentation. Very interesting, very comprehensive. I'm really thanking for all what you have said. I see there are two questions, one from Rob and from Benedict. And if time allows, I also have a question, but maybe others would like to ask other questions that pop up. But let's go for the first question from Rob. How do you see the data quality as a special concern of VGI being represented in the semantic web?
Okay, I suppose I was working on data quality in VGI for, I suppose, I consider myself one of the first groups of people working on this. And I suppose we haven't quite got on top of data quality in VGI just yet. I still think we haven't really defined what quality is for VGI. But to answer the question about semantic web, I think there's an opportunity there in VGI to provide a best of brand, a best of VGI, which could then be represented in the semantic web. But we're already seeing a lot of VGI from OSM, from GeoNames, places like that, which already is top of the class in terms of quality. But in terms of maybe extending that quality, maybe the onus is on academia to or the community in general to try to develop this best of VGI, which then can filter its way into the semantic web.
Perfect. Thank you, Peter. I have also a question from Benedict, and there's also coming up questions from Frans, Simon, and Christoph. So the question from Benedict is, how do you see OSM license promoting interoperability, especially with open data license rather Creative Commons like, CC like?
So this probably is best answered by someone within OSM, but from an OSM user and an OSM researcher's point of view, this is, I suppose, a sticking point. And I'm not sure which direction this is going to take. There may be a possibility in the future where there's an exploration of looking at a forking of OSM in some way, where we have a more open data license and a CC, versus the current approach. But of course, that has happened before and caused problems in the project. So I think the discussions are happening within OSM, and it's. I don't have the answer on how the OSM community will achieve consensus on whether they want to go with that open data license approach, despite the fact that the OpenStreetMap would benefit in the opposite way from open data licenses from other data sources that they would integrate with. I'm not sure, is my sound gone or has Joop disappeared?
Yeah, your sound was gone. Just
I'm muting myself. Sorry, we have now a question from Frans Nibben, and his question is: how could persistence of linked semantic data produced by academic research be improved? Question mark.
I know this is not easy in the digital sense, but I just wonder what exactly persistence, the exact nature of persistence Franz means there. This would be easier to ask if we were in a physical room.
Okay, maybe if Frans could send an email to Peter and have continue the discussion there, that could be very helpful. I think it's a very important question, by the way. Simon asked the question: what different role do you see for semantics versus machine learning in data integration? Interesting question.
It is a very interesting question, and I suppose the machine learning approaches to data integration are very much heavily reliant on good semantics, and the better and stronger those semantics are, the more wider domain specific maybe that they are, the better they are. So I think there's a role for both. I think if you're developing a machine learning approach to data integration, you obviously have to have the technical or the organizational side of the problem correct, but then you need the semantics correct. With deep learning and machine learning, of course, some of it we're not really understanding what's going on under the hood. So we have to make sure that we have a good understanding ourselves of what the likely outcomes of machine learning based on the semantics that we are providing. So I think at the moment we're seeing the semantics being used in machine learning in some of the examples I've shown, maybe at the beginning of what's possible, rather than the semantic element being the very ceiling of what's possible. I think we're starting out now, and we will slowly improve that in the future.
Thank you. Christoph sent his compliments to the presentation, so well done. I have a last question. Is you talked about opportunities, but in contrast with opportunities are threats. Do you also see some threats for more integrated approach to GI integration, or is everything great and wonderful?
I suppose, yeah, it's not a complete rose garden. Everything is not perfect, but I think, as I said, the picture from maybe 20 years ago and today is very, very different. There is a lot more data that's openly available out there. Open source software and even commercial software is more focused on making it easier for end users to integrate data sets. Obviously, licensing and obviously the concerns about reuse are going to be there and are not going to go away. And particularly as a double-edged sword, that the more opportunities we have for integration, probably the more questions and the more of these issues around the sensitivities about reproducibility, about the privacy, and about commercial sensitivity will happen. So that's a good thing. So maybe having these issues on one hand is a problem, but on the other hand is actually a very good problem to have.
Thank you very much, Peter. I see the time is ticking, so we have to close this session. Thank you very much for your nice presentation. Very helpful, as Christoph said, and very insightful. If people would like to contact you, they know, I think, assume how to find you, and all the best. And I would